The difference between the security team and the networking team. Two different groups, different budgets, different management structures, different calls to action, different key performance indicators that they have. So what we run into is a case where security team has identified some really great products, whether they come from Cisco or one of our other partners, to deploy security tools inline. So they can take proactive prevention and remediation of problems as they occur and secure the network. But the networking team is like, well, okay, you want me to deploy this thing inline? Well, isn't that risky? This makes me kind of nervous. In fact, we've actually had customers literally have their networking teams literally say, not in my network, you're not deploying that piece of equipment. So how do we bring these two groups together? And the security team is also worried about, okay, I got solution A and solution B. They do slightly different things. I might have an intrusion prevention system. I might have a web application firewall. By the way, I see that combination all the time. How do I deploy these different solutions together and do it effectively? And the networking team's like, whoa, 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 wait a second. What happens if these things fail? What's going to happen to my network when you put these things in? And then the security team's, well, okay, it has a 10 gig port, but it only does about 3 gigs of traffic. So I'm going to have to actually deploy 3 of these into the network in order to scale this out. So how am I going to do that? And the network team's, well, yeah, but what's it going to do to my network performance? You know, am I going to get calls from the applications people asking me, hey, you know, why is my applications running so slow? Why is the access so bad? And, you know, we've also had customers say, okay, we'll deploy this inline, but if there's any application or performance issues, yeah, we'll just completely ignore it and blame you. Right? I mean, this is not cooperative interaction here. Meanwhile, the security team's worried about, okay, I got these tools. How am I going to keep it updated? How am I going to maintain it? How am I going to swap it out if the hardware fails? How do I keep it up to date with all the latest signatures and latest threats? And networking teams are like, well, I have this redundant architecture and it fails over and all that, so how am I going to fit these tools into that kind of situation? I didn't build my network to deal with these inline tools. And then ultimately, who's responsible for it? When a problem happens, who do they call? And who's actually, you know, is this a tool, but it's inline, so is it a network gear? Everyone's confused. And so what GigaSECURE is, brings these teams together and allows them to deploy inline solutions in a way that's going to be scalable and extensible and mitigate and answer all these questions that they have. So I'm going to drill down a little bit and talk about our GigView HC2 product, which is part of our overall security delivery platform. Whereas normally you might have an inline tool, you know, like an intrusion prevention in between 2 nodes in your network. What we're going to do is we're going to sort of take that out and instead put the HC2 into the network inline and then hang the IPS off of that. Still inline, but we're the ones connecting directly into the network rather than the IPS. And by doing this, it makes the deployment safe and reliable. It's very easy to maintain. It's very extensible, and I'll show you some examples of that later on. And it's also consistent with what I call a multi-tier zero trust security strategy, right? Multi-tier, meaning I want to have multiple solutions deployed against multiple types of threats. Zero trust, which means I'm not going to trust anything. There's no trusted or untrusted part of the network. I am going to inspect and secure everything. So how does this actually work, you know, physically? So here's a little blow up. Where traffic comes in from the network, oops, let me see if I can slow that down just a little bit. Traffic comes in from the network, goes down to the IPS, back up, and then comes back to us, and then we send it through. So the red line, for instance, is traffic that's it hasn't been inspected yet. It's coming in from the big bad internet, for instance. Goes down through the IPS. The IPS says, okay, this looks good. We'll clear it. Becomes green, gets sent back and through into the network. Now, when we start drawing all these inline diagrams, they get very complicated very quickly, partially because everything is bidirectional. So now I have outbound traffic that hasn't been inspected yet. We're going to send that to the IPS. IPS sends it back out, all checked and clear, and then we send it off onto the network. So the dashed lines is the northbound traffic in this example. So in case you had, instead of an IPS, it could be data loss prevention and data extraction tools. Meanwhile, while this is happening, I can also replicate that traffic from either direction, or both, and send it off to an out-of-band tool. So even though I'm deployed inline, I am now actually also a point of inspection for out-of-band tools in the network. I'm basically now my own tab. So now I can take that traffic and send it off to other tools for inspection. So the blue line would represent then out-of-band traffic. Okay. And what we can actually do here is combine multiple tools together, and I can replicate or distribute traffic. I should say, we don't replicate the traffic, but we distribute the traffic across multiple IPSs in this example. So when we talk about replication, so one of the things that we do is remove points of failure in the network. Because when you have a device in the network, what happens if it goes down? Someone could equally ask, and it's a valid question, well, what happens if we go down? Or what happens if the tool goes down in this scenario? Well, we actually have the options to either fail open or fail closed. This is one of the most fundamental questions that you have to ask, or we have to ask security teams and networking teams. When a problem occurs and you cannot inspect the traffic for whatever reason, do you want to keep the traffic flowing, to keep your applications running, to keep your, your web access and your servers going? Or do you want to completely cut off your network to keep it secure, right? And that fundamental question really drives whether you fail open or fail closed. And it takes a long time for some of our customers to get to that decision about which one they want to do, because there's pros and cons to both of them. And with that in mind, we provide physical bypass protection against a power failure. So if you want to have the notion that, okay, if we can't inspect the traffic, we still want it to flow because we want to keep our services up, you can set up the HC2 such that if power is lost to it, we will close a relay and keep the traffic flowing in a fail-to-wire scenario.
Can you fail open for both copper and fiber connections through Gigamon?
Yeah, it's different pieces of hardware, depending on if it's copper or fiber, obviously, but we provide both options. And that's a perfect example when we talk about fail open or fail close. Depends on if you think of it from a networking term or from a electrical engineering term. Right. Everyone gets confused, and so I try to avoid those terms.
And presumably, because it's like with the electrical, presumably it's now a physical connection, so you better keep your cable lengths half of what the maximum is on each side of the tool, effectively, right?
Yeah, sure. I mean, it's a closed electrical relay, so you need to make sure that, if you're at a 100-meter cable, that you're actually not going 200 meters total. It's like only 50 on each side. Yeah, good point. And usually, depending on the deployment, the distances tend to be shorter for these types of inline. But then there's the question of what happens if the tool goes down, and how do you detect that, right? Because physically everything could be fine, but the tool could either lose power, it could just hang in software. What happens then? So we have a couple of means of detecting whether or not the tool is healthy, right? You can look at the link that we're connected to it, and we can actually also send heartbeats through it to validate, hey, are you alive? Are you well? What is the latency of this packet that we're going to be sending through you? And depending on the performance, we can actually determine if the tool is healthy or not. And if it's healthy, we can send the traffic through. And if it's not healthy, we give the user different options to either fail open or fail closed or take other types of bypass actions. So how do we scale this out now? If you try to take a tool that only does 3 gigs worth of traffic, and you have a 10 gig network, you can't just deploy more of them. It just does, in serial, it just doesn't work. You ended up stacking up your bottlenecks. So instead, what we can do on the HC2 is distribute that traffic across multiple tools. So this allows them to use the power of parallel processing and to be able to maintain sessions. So every single tool, like the top one, always gets the same packets of the same session. So from its perspective, it's the only tool in the world, and it's inspecting the traffic. So it's able to secure the network, 1/3 the network. The middle one does the other third. The bottom does the last third.
So are you guys actually shutting connections down?
Nope.
Via API? You're just passing it through and letting
We're just passing it through. In fact, we are so transparent to the network, they don't even realize, the network doesn't realize we're there.
Because, you're talking about, leaving a session open, session closed. which kind of tells me that via the API that I should be able to trigger something on your side to be able to shut something down, but then
Yeah, so we're not, basically what we do is we just take it and we perform a
handing it
traffic
off.
distribution via hashing. It says this, 4-tuple IP source, port source destination is going to go off to this tool, this other one's going to go off to the other tool. And though it is possible for you to, with an API, for instance, to send us a call that says drop a particular type of traffic.
okay.
Personally, I would rather leave that to the firewall. They're really good at that. But we could. But it's, our focus is to get the traffic to the tools and out with little disruption as possible.
So when you talk about leaving a circuit open or closed,
Yeah.
are you talking to, say, my IPS or whatever it might be? If it fails to send a trigger to Gigamon that says shut it down, is that how that's occurring?
Yeah, what we do is we actually send it what we call a heartbeat packet.
Okay.
Which by default is an ARP because those just get passed through. But you can also do a customized heartbeat.
And that's from the application, or from my...
Yeah, we actually will send that through from our CPU, insert it inline into the network traffic that we're sending to the IPS, for instance.
And then it responds back.
We get the packet back. We say, okay, it's good.
Okay.
But then we don't forward, obviously, to the rest of the network, right? So the network never notices that we're there. The tool just thinks it's passing some random packet. So that's how we determine its health. And you can set up windows for how long we wait for the heartbeat to come back. So you can judge and tune it to the latency of the tool itself. And you can verify, or you can specify how many heartbeats you lose before you declare the tool down. And then once it is down, you can decide, okay, do we just skip the tool, stop sending it traffic, and send the traffic through to the network? In the case of a group like this, we can decide, all right, I can redistribute the traffic to the other tools, or I can take the whole thing down if I wanted to, or I can also turn off my network links and say, nope, I can't inspect this traffic, this network is no longer accessible. Fail over to your redundant standby network if you want to. Right? So all these different options are available.
And not to mention the fact that you could have an N+1. So that particular group can have another.
Wait for it.
Sorry.
Next slide.
Next slide.
So, for instance, you can have built-in redundancy. I mentioned failing over to multiple tools, and then you can do.
And you even work for him. Or not for him, but for Gigamon.
Or you could set up one so that it's in standby mode and takes all the traffic from a failed tool. So it depends on budgets, it depends on deployment scenarios, and the deployment philosophy when it comes to security and bypass actions.
Can I get just a quick clarification then? So if you're in the line and you're shunting it off to an IPS and the IPS says, hey, this is a bad flow.
Right.
Then the IPS is going to trigger a rule to say, stop this flow. Does it have to send that back to you and then you stop the flow?
No, the IPS will stop it itself.
The IPS stops it itself.
Yeah, and we don't monitor, except for our heartbeats, obviously, we don't monitor the amount of traffic that we send in IPS versus the amount of traffic we get out of it. Because if it drops packets, we're not going to judge. So that's the IPS's job. Or in some cases, they will make an API call to the firewall. And the firewall will drop it. For instance, that's another scenario. So we're not really in the business to decide and make those drop decisions or to do the dropping. The tools are really good at that. Let's keep them doing that. Okay. So this also allows you to reduce your maintenance window. So now that I have 3 tools in this example, and they're all parallel processing, I can take one offline. The other 2 are still there protecting the network. I can update it, I can replace it physically, I can do any types of things with it without bringing down the network. And I can just first do the top one, and then do the middle one, and then do the bottom one. So I can really keep my network secure, and it's not being brought down, or it's just a lot easier to do in a smaller amount of time. Okay. So now if we start talking about, or I should say, I've talked about the same tool, right? The same IPS from the same vendor. What if I have different types of tools that are looking at different types of traffic and monitoring and protecting against different types of threats? If I try to put these all in serial, that's now 3 points of failure, each of which is adding its own latency to the network, and each of it may not want to see all the traffic. Well, the same basic principle applies, so that what we can do is send different traffic to different tools, or we can serialize them and send the same traffic to multiple tools in line. So your network, instead of having 3 points of failure in this case, still has us with the bypass protection. So your 1 point of failure that's bypass protected, and then we can distribute the traffic across the 3 tools safely. And so here it's more like serial processing, where we can do it in serial or send specific traffic to specific tools. A lot of cases, for instance, where I mentioned IPS and a WAF, where the IPS wants to see all the traffic. The WAF only cares about web traffic. So in a serialized fashion, we'll send all the traffic to the IPS, and then it comes back from the IPS, and then we just extract the web-based traffic based on the port 80, 443, whatnot, send that off to the WAF, and send the rest of the non-web traffic through to the network. So the WAF doesn't even know that other traffic exists, doesn't have to worry about it, doesn't have to waste its precious processing time on it. So I mentioned removing points of failure. Oops. And that's really allows you now, you can imagine now it can scale out to any number of different types of solutions for inline security. So for simplicity's sake, I sort of drew one vertical line, but networks aren't always just a single line coming in. There's a lot of multiple network links that need protected. You could have redundant networks. You can have a campus environment where you have multiple edges. And all those can be combined. For simplicity's sake, I've drawn a single tap point here for each point, but the HC2 is actually still in line. It's just I just shunted it off to the side in the diagram, where now the same device can now monitor multiple network links, send that traffic to the same tool. So you can actually optimize your investment by having one tool, let's say a 10 gig tool, that's monitoring multiple 1 gig links across the campus or across the network, depending on how the network is architected. So this allows you to share inline tools across your network, reduce your CapEx, and get the most efficiency out of the security tools you're deploying.
From a physical standpoint, what's the topology look like here? That I assume the HC2 is a box, right?
Yeah, so the HC2 is a box, and so what I want to do is actually take each of those green lines, break it, send it to the HC2 and back out. But you can imagine that gets really messy when I start drawing it on a PowerPoint.
So can you elaborate on the? I guess I'm missing how the HC2 or the HC series, I suppose, does anything beyond simple TCP load balancing. Is there any value above that it's providing?
So in terms of application load balancing or those types of...
essentially taking a TCP flow and maintaining that state across whatever device you say I want to send this flow to, making sure that that's balanced through some sort of rules. Yeah, there's a million tools out there that I can use to do that. So what does this do? Right.
So first of all, we're focused on being transparent to the network, and adding minimal latency. Right. We're talking microseconds worth of latency rather than milliseconds, so that we're not impacting the performance of the network. So when the traffic comes to us, because we're just completely transparent and sending that traffic off to the multiple tools, and we can do this very quickly, and we do it in hardware, we're not actually having a physical or practical impact onto the network. So it's different and a different focus than an application load balancer, right? Load balancing in terms of distributing traffic is one of the things that we do, but it's all in the context of supporting this parallel processing of multiple inline tools. If you try to do this with a processor-based type of solution, you're going to negatively impact your applications. Okay. You're going to add additional latency, and you may or may not get the bypass protection that we provide.
Okay, so your view is that you do this at a better performance than the alternative.
Yeah, because we're dedicated as a visibility platform, and we're just applying that same mindset to an inline visibility as part of an overall security delivery platform, so therefore we were able to provide the better performance and provide better security overall as part of your overall visibility strategy.
Okay.
So your focus is getting that data to these other applications as quickly as
exactly,
so that can be processed.
Yeah. It's getting the right data to the right tools.
And I can view my specific sets of data via an API or whatever. Like if I'm an IPS or whatever, I can make an API call and only look at security.
Yes, yeah. So as an example of that, initially the users, it's amazing sometimes how little the users know about the traffic on their own networks, right? So they may just deploy an IPS and says, okay, start securing the network. And after a while, the IPS realized, okay, I don't need to see everything. I like to focus on these specific flows. And so they, through the API, can specify what traffic it wants to see from us.
So you're actually, when you see the data, you're actually processing that data with, say, like your own version of an IDS, or to be able to carve that data up, right?
So we are, let me make sure I'm saying this correctly. When we forward data, it's basically,
raw?
for inline applications, it's based on layer 2, layer 3, and layer 4 field information. So we just look at the packet, look at the IP source destination, look at the port addresses, and send it off. So we're not doing, for inline traffic distribution, not doing a deep dive up to layer 7, right? Because that takes time, that takes effort, and that adds performance issues. So we're all about hardware-based distribution and forwarding of traffic, right? So we don't actually perform any of that processing that you're implying that we do.
Right.
We'll let the tools do that, but we can pre-designate what traffic they see.
So you're doing some sort of process. After you hand it off, you're processing that data. So some other tool might say, hey, I need to look at this data because, for whatever reason.
Yeah, I'm hesitant to use the word processing because we're not a processor, and therefore I'm not actually
an overview of the data.
Yeah, it's.
I mean.
Yeah. We do this at a silicon hardware level, of basically looking at the 4-tuple typically and sending it off based on the map rules.
Okay.
And another way that customers have deployed this is where you have like an active and standby network with redundancy, each of which is protected with their own set of tools. And so we can make the decision in this case of, if these tools fail, we can close down that side of the network so it fails over to the redundant side of the network with its own tools. And so you maintain redundancy and resiliency within the network. So you have all these different options when it comes to deploying security tools in line in a way that's consistent with a highly resilient and highly redundant network architecture.
If you have like router on a stick or firewall on a stick in a data center, and you want to sit in line, say it's transparent firewalls, you're going to see the traffic coming in twice. So how do you handle that?
I'd have to see a network diagram to figure it out. When you say when we see the traffic twice,
say you have some sort of a device just hanging off of your network, and you're routing traffic that way. It's routing it back, or it's bridging the traffic. So you're going to see those packets in there twice, and be sending them likely to your IPS and your monitoring appliances twice. So is there any way that you can look at like VLAN tags or anything like that and not necessarily pass that traffic to those appliances?
Certainly, and VLAN tags is one of the ways that we can identify what traffic to send to specific tools. So if you say that, oh, this particular VLAN has already been inspected, we don't need to see it again or send it off to another tool. You can certainly say, okay, we're going to take those VLANs or subnet or however you want to define that, and not send, and just bypass it to the network. Say, okay, this has already been inspected once, we don't need to do it again. And let me back up on my slides way back to the beginning, so I think it would just be easier to explain. And let me go to this one here. So it also depends on the physical port that it's connected to. So if we're in line twice, looking at two network links, one of which is redundant with the other, so they end up being we see it once, it goes off to tool, then comes back and we see it again. You can just specify the one link goes to the tool and the other link doesn't go to the tool. So you can do physically based on how it's wired, or you can based on VLANs and if they're being added by the inline firewall or whatnot. So there's different options that you can deploy to avoid sending replicant traffic to the tools.
Okay, thanks.
Okay. Now I'm going to have to fast forward through the rest of it. All right. So in summary, so when we talk about multi-tiered security, what we actually now want to do is start combining everything that Ananda talked about earlier, where I have my intrusion prevention system seeing things inline, that's a thick green line, but I can also now, as I mentioned before, replicate that traffic to an out-of-band tool. So that could be a capture tool, that could be intrusion detection, it could be a forensics tool, whatever it happens to be. I can also take that same traffic and generate NetFlow from that, and we do it unsampled, so that now your NetFlow-based security tools can see the exact same traffic and get the exact same flow information that your inline packet detection devices do. And I can also monitor my network performance. And one of the things I tell the network engineers, are you worried about the performance of this inline security tool? Well, you can actually test the latency before and after we send the traffic to it, so you can know exactly what kind of impact it is having on the network. And you can see whether or not you're having a problem at that particular point in the network. And basically any number of tools, because it's now part of the visibility fabric. It's part of your security delivery platform, which includes non-security tools as well. So you can really do anything with this traffic for out-of-band monitoring at that point. So one of the ways that we integrate with RESTful APIs, as I mentioned before, the user through our GigaView FM can send API calls to our device to specify what traffic to send to which tools. So you can tell it to bypass trusted traffic. If you know that a particular traffic is trusted, or you're not worried about inspecting it, you can bypass it and send it directly through without inspection. You can also capture suspicious traffic. If you've identified that this looks a little hinky, it's a rarely used subnet, it looks a little suspicious, you can send that traffic off to a specific tool. And these types of commands can come from the tools themselves. It doesn't have to come from a user. And so this is where the RESTful API and the infrastructure and the ecosystem that we have with our partners really helps. So now they can make proactive decisions at 2 o'clock in the morning without calling up a security engineer that says, hey, there may be something suspicious, let's do something and let's inspect it in a different way.
So going back to the thing on shutting it down, the connection if a tool fails.
Yeah.
If I'm running whatever the tool is in the back end, if I'm doing logic on that data, and I say that my default action is shut the link down, but my tool says shut it down, assume the default unless I see this. Is there a use case for that? Where maybe, say, it could be a syslog server, right? You might be sending syslog to it or whatever, and you're actually parsing that data, and your default action is shut the link down unless I see this, where I might want to leave that connection open, and send that API call back to this and say change that default behavior. Does that make sense where I'm going with that? There's going to be exceptions. I'm just thinking there might be an exception to. Yeah.
So when it comes to there are two levels. One is the default actions and what the user specifies when they set everything up. That says, how do you want Gigamon to behave in the event of a tool failure?
Right.
And then there's what the tool is telling us to do via an API, which is the equivalent of a user telling us to do something. So these exceptions that you're talking about can be set by the tools themselves through the API script.
Yes, that's
so at that point you have complete flexibility on what policy you want to set.
Right. Okay.
So it's completely up to whoever's setting up these API scripts, working with the tool vendors and working with the overall architecture and say, do I have a backup standby network to fail over too? Right. So it just depends, and we have that total flexibility.
Okay. But you're seeing people do that, I would assume.
I'm not seeing people specifically do, I think what you're saying.
I think I could probably go on a little bit more.
But there's, we're actually just scratching the surface. We just introduced the RESTful APIs this year, and so we're ramping up our ecosystem partners to interact with these and to get the best use cases out of them. So it's an ongoing process.
I'm just thinking a use case where you might see a specific behavior where you might want to allow that traffic for a certain period of time to get more information on it.
Sure, yeah, absolutely. Because if you have an inline device, by definition, they want to start blocking traffic. But the other philosophy is, let it run, but we'll monitor it. And then if there's a problem, we can always remediate it.
Right.
Because the philosophy that people are moving to, some faster than others, is the bad stuff is going to get in.
Sure, absolutely.
So it's a question of what you do with it after that. So the inline tool can take a stance that says, you know what, I'm not going to block this. It's suspicious, but it doesn't reach that threshold. It's a yellow, not a red, right?
Because I could also see where you might have another tool that would do additional deep level
Absolutely.
That I
That
can
could
send
be-
an API call and say redirect that traffic over here.
Exactly, and that could be an out-of-band tool that has, sitting on a virtual server that has a lot more bandwidth
Right.
and a lot more processing available to it,
Right.
a lot more capture capability. So that's exactly what you would use the APIs for. It says, hey, you take a look at this.
So let me add a little bit more color to your question, right?
Do you see where I'm going with that?
Yes,
Okay.
I understand what you're. I don't see the exact use case.
I'm not even sure I do.
For your. But I can see. So let me tell you. Let me tell you
I might
some.
come up with.
Right. Let me tell you what we're doing with JDSU Viavi now. Right. They've got this product called Observer. So working with them, they're integrating REST calls from Observer into the fabric. So what Observer does basically, right? It's a network recorder.
Right.
Everything
Right.
goes in. We're feeding them. They're seeing some patterns
Right.
of interest, and they can then say, you know what, from this whole pool of traffic, I want to see just those particular flows and send those to
Over here.
actually a different observer
That's
for
exactly where I'm
deeper
going.
analysis.
Right. Yeah.
Okay? If you didn't have REST, you
wouldn't
would
be able
have
to
to
do it.
have a human observer
Right.
looking at all the traffic, getting an alert from maybe the GUI saying, "Oop, there's activity that I've not seen yet.
Right.
Let me go and do this over here and figure out what that is."
Right.
With the whole REST capabilities, right, JDSU can now put filters, additional filters on our traffic, whether they're egress filters or actual change the flow maps, what we call flow maps, to say, send this particular traffic based on these tuples over here.
Right.
And let's see what we can find more.
And then if I find out more, I can send a call back to, and then shut
Right.
it down.
But this is all working with in collaboration with our partners
Right,
to
right.
make
You're just
sure
providing that
yes,
communication.
we're exposing the proper REST calls. They know how to consume and actually put
Right.
the triggers, the events into triggers that would do something on the fabric.
Yeah. That's exactly where I
Yeah.
was going with it. Right.
Now, this off the back of that, then you're in line, so you're in a great position to actually drop the traffic if you want to. Are you in that business, as it were? So, in other words, can one of the API calls be from the IPS system? This guy's bad. Please drop his stuff.
So as Patrick mentioned, that is not our function, right? Our function is to provide the tools, the traffic they want. Now, if your particular use case is a tool that says, you know what, I see all this bad stuff coming and I could stop it before it hits the network period, let's push a call to Gigamon to stop it. Yeah, we could do it. That's part of the thing that we've got with ASF, with application session filtering, where we can say, you know, YouTube or Netflix or any other streaming service that isn't necessarily beneficial for my business or for my tools to process, I can say, don't send that to my tools. I don't need to see it. I can say even further than that, you know, if you've got a firewall out there that is, you want to block it, you can probably program it to block it.
Yeah. Yeah, so just to be clear, ASF right now is all out of band.
Yes.
Right, so we're not going to be doing that for
Absolutely.
inline. But to your point, to your question about whether or not we could block traffic, the answer is yes. I don't really, personally, this is Patrick's opinion. I don't want to be in that business.
Right.
I'd rather have the inline tools do it themselves once they've identified the traffic, because they can still continue monitoring that traffic and decide to stop unblocking it. It's just much more efficient that way. You can, however, set up rules for the flow maps that says these particular types of traffic drop based on layer 2, layer 3, and layer 4 information.
Right, and I'm thinking particularly of the tools that are sitting there, whether it's the NetFlow collectors and stuff. They're not inline. They're getting data about it.
Yeah.
They look at it and go, ruh-roh.
Yeah.
Right.
There's nothing they can do about it other than flag up and throw it in with the other 20,000 alerts you have.
Yeah.
Right. So it's kind of a shame in some respects that you're not in that position, because you're right in line. You're in the perfect position to have an integrated suite of tools and the APIs in place to take action on that stuff. Or, you know, heck, push it off to a different different destination, a honeypot the stuff.
Oh, yeah, no, and
because you're
actually-
really in that weird space between the Ethernet switching fabric and the monitoring fabric, because you're in line. You've smacked yourself in the middle of it, and you
And it looks
have,
like-
you know.
It looks like to me you've positioned yourself just to be the single point of entry for directing traffic.
Yeah.
You know, being that all my applications, my tools are specific, but I'm going to use the Gigamon solution as my director to be able to send that traffic theoretically. Redirect it over here, inspect it additionally.
Yeah.
If it looks good, send it over here. And if this doesn't look good, shut it down.
Right. Yeah, and
I mean, I may be taking it way out into.
yeah, I think that it's a very interesting discussion to have and an interesting direction for us to go. Hasn't been our focus because it puts us in a role that I'm not yet prepared to take that step. But in terms of redirecting traffic to honeypots and those types of activities, we're absolutely built to do that. Okay. Thought I was going to get interrupted there. So another major use case, I have to back up so I can show you this example, this animation, where a lot of the inline tools started their life as an out-of-band tool. An IDS became an IPS, or an out-of-band anti-malware solution decided, no, we want to be inline for marketing reasons. Not necessarily performance, but for marketing reasons, we want to be inline. And there are some tools that actually need to first learn what is going on in the network. They may spend a couple of weeks just sitting there looking at traffic before they feel comfortable taking action against it. So they actually want to tune themselves to the network for a little while before going to an inline mode. And Gigamon can actually help that transition, because what we can do is connect the tool to the HC2 as if it were inline, but we're only going to send it out of band traffic. Then at a certain point, we can transition that through software and say, okay, now start sending it inline, and when it's a bidirectional traffic sending to and from that tool. So this will help customers not only transition tools that want to go from from out of band to inline, but also helps them evaluate tools and to verify, is this a solution that is providing us good protection that I want to put into my network, right? So they can put it initially out of band and then transition it to inline. And furthermore, this is a transition that the tool itself can make the decision, right? If it says, I want to learn the network for the next 2 weeks, once I'm confident, I can now put myself in line by sending an API call to Gigamon, rather than flag a user and they have to go in and reconfigure things. And we can do this just via software once you've wired it initially. So you don't have to have an additional truck roll to send someone else out to re-plug in things and have to reset links and all that. It's all been set up. We're just changing how we're sending the traffic and receiving the traffic from that tool. Okay. So in summary.
I have a question.
Yeah.
I won't go as far as I did before, I promise. Maybe this isn't even valid. But if you're receiving the traffic,
yes,
can I set priority on ports on where I send the flows? Is there a need for that?
So
where I'm going with that, if it comes in?
Yeah. So we don't set priority based on what traffic should go to specific tools based on some user-defined priorities.
Like a workflow. I mean, can you do like a workflow?
Yeah, it's not something that we're doing. From the tools perspective, right, they're just connected to the network. They don't even realize that we're there. We're not pre-sorting the traffic for them. However, you can, through the power of inline flow mapping, to say what traffic goes to the tool. That's kind of a very binary, low-level prioritization. It's either send it or not send it, right, and just bypass that traffic. Because we're hardware-based and we spent 10 years developing the notion that, yeah, we're going to send the traffic to the tools as quickly and as transparently as possible. We just transitioned that to inline. So we're not doing any type of queuing or anything that might impact how those packets get to the tool. If the packets are out of order in the network, they're going to be out of order when we send it to them, right? We're not doing any type of session-based or anything like that. So in summary, with GigaSECURE allows you to see more so you can secure more. And by deploying Gigamon inline and using GigaSECURE inline, you can protect the network and your flow of traffic using both physical and logical bypass. You can enable all these different inline solutions and multiple solutions from multiple vendors and scale it out across your infrastructure. And this is part of your overall security delivery platform. combining inline protection as well as out-of-band inspection and monitoring, as well as integrating, packet-based tools as well as NetFlow-based tools. Okay. So, any final questions before I hand it off to Noam? Yes.
Yeah, I have a question. You said you don't look at the so let's say I've got some SQL traffic and I want to forward that, send it to my WAF. Do you just look at the destination TCP port, or how do you?
Yes, that's what we just look at the TCP ports, and based on that, we can send it off to the WAF, or not send it off to the tool if it doesn't care about particular types of traffic. So, and that's in order to keep up speed, and because this is done at a hardware level, and doesn't require any extra processing and queuing, and very low latency. So.
What if the user is using some proxy HTTP server? So now everything is 4K.
Yeah.
How do you test out there? Are you still able to classify and know that this this packet is carrying SQL or some other HTTP traffic?
Yeah, if everything is over port 80, things get a little trickier. There are certain tools that we have to define what we call user-defined attributes that can actually look within the first 120 some odd bytes of the packet. But that's not, may or may not be applicable depending on the application, right? So my best answer that I can give honestly is it depends. But it is certainly a challenge when you're talking about inline, because we don't want to be an impact on that. But for out-of-band inspection, where we have other tools like ASF that we can deploy and extra traffic intelligence to look deep within the packet, certainly we can make those decisions.
So it is possible for a user to use a proxy server and bypass your appliance?
But that's not where they're positioned at.
To use a proxy server to bypass our appliance, well, the traffic's still going to come through us, and then at that point we can make a decision whether to send the traffic to the inline tool or not. And so it just depends on how they have that set up.
Physically be able to serve.
Yeah, I mean the only way you're going to, because we're physically connected inline into the network, so you can't bypass us in that respect, because we're still going to get the traffic, but we may, depending on how the users have set up the inline flow mapping, send that traffic straight on through. We could potentially drop it, or we can send it off to inline tools. Those are sort of your three basic options.